Hello students, here I am going to discuss the topic of recursion, which is the most important topic in C problem solving using C. Uh, Today's discussion, what is recursion? There is some what is important, what is recursion, some examples we can you can better understand through these examples which I have mentioned in the PPT. Recursion, mechanism of recursion versus iterations, function calls, implementations. These are the important factors. Recursion, a process by which, what do you mean by recursion? A process, a function, a function is a function which is going to call itself again and again up to a specific number of times. This particular concept is known as a recursion, a process by which a function calls itself repeatedly. Such a function called a recursive functions. Recursion may be directly or cyclically in a chain. Direct recursion means when a function f calls f, but when a function, when you in these examples of the cyclically in a chain recursion, f1 calls f2, f2 calls f3, f3 calls f4, f4 calls f5, f5 calls f1. In the case of the cyclically in chain recursion, when a function calls itself again up to a specific number of times, it is known as direct recursion. Means function f call that is itself f, again function f call f, again function f call f, up to a specific number of times, it is known as a direct recursion. But when a function f1 calls, but when a function call f1, and within the f1 function f2 calls, but when within the f2 function f3 function calls, within the function f3 f4 calls, within the f4 function again f1 calls, this is known as cyclically in a chain recursion. So there are the two important points in the recursion. That is, first is direct recursion and second is cyclically in a chain recursion. There you can better understand the concept of recursion in the two examples. One is factorials and other is Fibonacci number sequence, and a lot of different type of examples by which you can better understand the recursion. That is factorial, Fibonacci, GCD, greatest common divisor, Tower of Hanoi, and a to power b. How you can find the value of a to power b? You can create the particular program through the recursion to calculate the value a to power b. But in this, there are a lot of different type of program or exercise by which you can create a multiple number of programs using the recursion. But here the common used is that is factorial calculations, factorial, and you can better understand in mathematics factorial is equal to n into n minus 1, n minus 2 dash up to 3 to 1. What are the Fibonacci numbers? 1, 1, 2, 3, 5, 8. You can better understand 1 plus 1 that is 2, 1 plus 2 that is 3, 2 plus 3 that is 5, 5 plus 8 that is 13, and 8 plus 13 that is 21. So if you are looking in case of the Fibonacci numbers, in case of factorial numbers, you can better understand that the factorial n is equal to n into factorial n minus 1. This particular factorial function call itself again, but the value of the number is to be decremented. Means first the function is the function factorial is to be called when the value when the value is to be assigned, that is n. When this function next time the factorial function is to be called, the value is to be n minus 1. When again this factorial function is to be called, then the value is to be n minus 2. When again the function is to be called, the value of the input that is n minus 3. So the value of the n is to be decremented up to the 3 to 1, up to the 1. When factorial function is to be called itself and the input value is to be 1, then in this scenario this is the last chance to call this particular factorial function when the input value is to be 1, and this condition is to be known as a base condition. So next example is Fibonacci numbers. Here when you can analyze the sequence 1, 1, 2, 3, 5, 8, 13, 21, you can better understand that ni is equal to ni minus 1 plus ni minus 2. That is Fibonacci n is equal to Fibonacci n minus 1 plus Fibonacci n minus 2. This is the generalized. You can understand, generalize, and you can get the particular expression ni is equal to ni minus 1 plus ni minus 2. Conditions for a function to be written in a recursive form. Two conditions are to be classified, condition 1 and condition 2. It should be possible to express the problem in recursive form. Second, the problem statement must be include a stopping condition. This stopping condition is known as a base condition. It should be possible to express the problem in a recursive example factorial n, that is you can already stated in the previous slides. Here you can say that factorial 0 is equal to 1. The problem statement must include a stopping condition. What are the stopping condition? A stopping condition when the value of n and when the value of n is equal to 0 means factorial 0 is equal to 1, and when the Fibonacci 0 is equal to 0 or Fibonacci 1 is equal to 1, these in the above example factorial 0 is equal to 1, this is the base condition, and in the below examples, Fibonacci, in the case of Fibonacci 0 is equal to 0 and Fibonacci 1 is equal to 1, this is the base condition. So in every problem, if you are going to discuss each and every recursive program having the base conditions. Some examples to be, that is a C program to calculate the two power of numbers using recursion, where the example is the exponent is to be whole numbers. You can better understand that. That is how you can calculate the a to power b. Means if a to power b means b means exponent, a ki power b means what is a? A means base and exponent, that is b. So if exponent is 0, you better understand that base 2 ki power 0 is equal to 1. If exponent is to be 0, then the value must be written, that is 1. This is the base condition. But if base 2 power exponent and means, for example, 2 ki power 3, then in these situations this recursive function is to be called means the power, you can calculate a to power b, or means base 2 ki power exponent. The value of this particular expressions you can call the user defined function. User defined recursive function means power in which there are the two parameters to be passing, one is base and another exponent. But in this scenario, when the power function is to be called, each and every time the exponent will be decremented. Means when the exponent is for example, if you are talking about 2 ki power 3, then firstly 2 into 2 ki power 2 means 2 ki power 3 becomes 2 ki power 2. So the exponent is to be decremented 3 to 1, 3 to 2. So 2 into 2 ki power 2, 2 into 2 ki power 2, 2 ki power 2 becomes 2 into 2 ki power 1. 2 ki power 1 becomes 2 into 2 ki power 0. Means each and every times, the particular exponent will be decremented. So by this recursive function, in this example, recursive function is that is power, by this recursive function you can going to slowly you can going to the base conditions, and when the final when you reach the base conditions, the at the end all the values to be calculated, and all the intermediate value will be compiled or calculated, and the result will be given. Recursive function for factorial n. In this example, you can better understand that in a main function, if you want to get factorial of a given numbers, in this example the given number is x. So how can you get the factorial number? You can create a user defined recursive function. In this program it is mentioned as effect. Here effect n means if n is equal to 0, return 1. This is the base conditions. And if n not equal to 0, then but obvious n into fact n minus 1 means if you are going to calculate the factorial value of 3, then the value of n is to be 3. 3 is equal to 0, it is wrong, so control going to else. Then 3 into fact 2, then again the value of the input argument, the input argument of fact will be new, is to be new, means it is 2. Then the value of n is to be 2. So it becomes 3 to 2, and the again the value of n, that is not equal to 0. So control goes to else, and now 2 into fact 1. So in this scenario, the fact function is to be called again in this scenario, and it is finally it will jump to the base conditions, and you can get the final result. It is factorial 3 means 3 into 2 into 1, factorial 1 means 3 into 2 into 1, that is 6. In this example, you can better understand that what factorial 4 means. If 4 is equal to 0, return 1, else return 4 into fact 3, but obvious 4 not equal to 0, then not return 1. So 4 into fact 3. The next target is calculate fact 3. The fact 3 means 3 into fact 2. Now the next target is fact 2. Calculate the fact 2. Now the value is 2 into fact 1. What will be the fact 1? 1 into fact 0. So you better understand that to calculate the factorial of a 4, you can call the function, user defined recursive function 1, 2, 3, 4, 5. You can call the fact function 5 times to calculate the fact 4. Means fact 4, fact 3, fact 2, fact 1 and fact 0. These are the 5 times fact functions, user defined recursive function is to be called to calculate the factorial 4. So these are the 4, means you can better understand that is 4, 3, 2 and 1. These are the intermediate results. These intermediate results is to be stored in a stack, and you can put top 2 elements from the stack and multiply, and then put back in a stack, and then again next top two elements put to pull out from the stack and multiply, and then insert a particular value in a stack. Then in this scenario finally you can get a single number in a stack, and this will be the final result. So you can understand this, the concept of in the concept of recursive function, you can use the stack. You can use the stack, means all the intermediate results are to be stored in a stack. So in this example, you can better understand that there is one by one this particular fact function. So this is the concept of the recursion, by which a function must be called itself again up to a specific number of times. So in this example, fact 4 function is to be called up to 5 times. So this is the concept of the recursion. You can see this. Now next is recursive Fibonacci series. Fact of f0 is equal to 0 and f1 is equal to 1. Fn generalized form. What is the generalized form? For the n greater than 1, fn is equal to fn minus 1 plus fn minus 2. So these are the fifth Fibonacci number is, sixth Fibonacci number is, that is you can get the result for in these situations. You can better understand the Fibonacci series through this chart. Fibonacci series, that is f4. F4 means f2, f3. Here the value of the n in a Fibonacci series execution, the value of n is to be 4, means f4 is to be 2. There are the two parts, f3 plus f2. What will be f3? Means f2 and f1. What will be f2? Means f1 and f0. And what will be the value of the f1? f1 means 1 and f0 means 0. So the function is to be called f4 call f4 call, then you can get the result f3 f2, f3 call, then you can get the result f2 f1, and f2 call, then you can get the result f1 f0. When the function f1 call, it will be you can get the result that is the 1 and F0 for 0. So in this scenario 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times function f calls, Fibonacci function f calls to get the result. But in this scenario, f1, f0, when the recursive function stop the calling itself, this condition is known as base condition, and at this stage you can summarize all the intermediate results and compile and calculate and get the final results. So here in this situation this is the example of Fibonacci series. Yeah, you can better understand it. Calling 9 times. I have already said that is in this scenario 9 times function f calls, and by the 9 times function f calls you can get the result. You can get the final result. So if f5, if you are getting the result of f5 and f10, then the number of function calls to be increasing is going to be increased. Recursive versus iteration, repetitions, termination, both can have info. What is the that is two are different. Mostly students confused. What is the iteration? What is the recursion? Recursion. Here are the basic most basic points. Repetition, iteration, explicit loop, recursion, repeated function calls. They are the 1, 2, 3, 4. 4 parameters by which we can differentiate recursion and iterations. Repetitions in the context of the repetition, iteration, recursions, termination, iteration, loops, condition fails, recursive base are recognized. When condition fails, the iteration not be continue. But in the case of recursion, the function call again until or unless the base condition recognized. Both have infinite loops. Be careful about the termination condition, balance, choice between the performance and good. Software engineers, that is recursion. So these are the students, these are the recursive concept, and through this video you better understand the recursion when you creating the some programs, means Fibonacci, factorial, Tower of Hanoi, and GCD, and some others are the most some others are the important programs. Here you see this slides. You can create the particular programs to solve the particular programs through the recursion. If you are creating or solving this particular problems through the recursion, then you can better or best way control in the concept of the recursion. Thank you, students. Jai Hind.